This is section 3 for exponential and logarithmic equations. We're going to solve these equations. And it says solve each exponential equation exercise 1 through 22 by expressing each side as the power of the same base and then equating exponents. So we have 3 to the 2x plus 1 is equal to 3 to the third. Now they're to the same bases. So if these are truly going to be equal, then 2x plus 1 better be equal to 3. So 2x is 2, x is equal to 1. These are base 5, so 5 to the third. So 5 to the third, but there's already an x up there, is equal to 5 to the fourth. So 3x has to equal 4. X is equal to 4 thirds. This one, this is 7 to the 1/2 power. Square root and 1/2 power are the same thing. So x minus 2 over 6 has to equal 1/2. Multiply by 6, that is half of 6 is 3, so x is equal to 5. Here we can get them to the same base. We have 2 to the 2 to the third. 2 to the third is 8, and that's 1 minus x. And 4 is 2 squared, and there's already an x plus 2 there. So 3 minus 3x has to be equal to 2x plus 4. So let's add 3 over and minus 4. So negative 1 is equal to 5x. X is negative 1/5. Solve each exponential equation in 23 to 48. Express the solution set in terms of natural logarithms or common logarithms. Then use a calculator to obtain a decimal approximation. Correct to 2 decimal places for the solution. So let's divide each side by 4. And I got a handy little calculator over here. 10,273 divided by 4 is 2,568.25. And now we can take either the log or natural log or whatever we want. We can take the log of both sides. I'm going to choose natural log. I almost always choose natural log, but especially when we have base e. So these have the same bases, so that's just 7x is equal to the natural log of 2,568.25. So x is equal to the natural log of, well, this answer. And we're going to divide that by 7. We get 1.12. It said 2 decimal places. Normally we go to 3, but it says 2 decimal places. Here we don't have to divide first. I'm just going to take the natural log of both sides right away. We can bring this power down and divide by natural log of 5. So we have the natural log of 137 over natural log of 5. Natural log of 137 divided by natural log of 5. And then, that's x minus 3, so we're just going to add 3 to this. And we get 6.06 rounded to 2 decimal places. On this one, we can take the log of both sides. We can take common log. We can take natural log. Let's take common log. It doesn't matter. It's going to be the same answer no matter what. Log of, that's going to be 3. Log of 3 to the x plus 2. And we can bring the powers down in front. So 2x plus 1. Log of 7 is equal to x plus 2. Log of 3. And let's distribute log of 7. So 2x log of 7 plus log of 7. And we'll distribute the log 3. So x log 3 plus 2 log 3. Now we're going to move anything that has an x, we're going to get to one side. So 2x log 7 minus x log 3 is equal to 2 log 3. Now this one doesn't have an x, so let's get it to the other side. Minus log of 7. And we can factor out an x. So 2 log 7 minus log 3 is equal to 2 log 3 minus log 7. And then we're going to have to divide by all of that. So x is equal to 2 log 3 minus log 7, and then divided by all of this. So 2 log 7 minus log 3. All right, so that's half the battle. The other battle is getting this entered into the calculator correctly. So 2 log 3 minus log 7 divided by, and we'll put this in parentheses, 2 log 7 minus log 3 in parentheses. So 0.09. 0.09. Well, let's treat this like, how should we do this? Like we're just going to factor it. And instead of having x's here, we have e's. So this is going to be e to the 2x and e to the 2x. And when we FOIL, e to the 2x times e to the 2x is e to the 4x because you add powers when you multiply. And then factors of negative 24 that add up to 5 are plus 8 and minus 3. So e to the 2x plus 8 is equal to 0. Well, e to the 2x has to be equal to negative 8. But you can't raise e to a power and get negative 8. So this piece doesn't yield an answer. But e to the 2x can equal 3 on this one. Let's take the natural log of both sides. Natural log of 3. We can bring the 2x down. These actually cancel. So 2x is equal to natural log of 3. So x is natural log of 3 over 2, and we'll get the decimal value for that. Natural log of 3 divided by 2. 0.55. 0.55 rounded to 2 decimal places. Now instead of e, what if we had 3's? This would be 1 times 3 to the 2x plus 1 times 3 to the x minus 2. So that means, your a is 1, your b is 1, your c is negative 2. So this factors into 3 to the x. 3 to the x equals 0. So that's splitting up 3 to the 2x, and then we'd have a plus 2 and a minus 1, and that would get us a plus 1 in the middle. Well, 3x plus 2 is equal to 0. 3x is equal to negative 2. Can't happen. Can't raise 3 to a number and get negative 2. Then we have 3 to the x minus 1 is equal to 0. 3x is equal to 1. We're going to take, you can take the log of both sides or the natural log of both sides, anything you want. Well, let's take the natural log. But, we can bring the x down. This is 0. So x is equal to 0 divided by natural log of 3 is 0. But maybe we could have recognized up here that 3 to the 0 is going to give you 1. So x equals 0 is the only solution. Well, let's check it. We have 3 to the 0 plus 3 to the 0 minus 2 should equal 0. 1 plus 1 minus 2. 2 minus 2. We found a solution. Solve each logarithmic equation in exercise 49 to 92. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Give the exact answer. Then, where necessary, use a calculator to obtain a decimal approximation. Correct to 2 decimal places for the solution. Well, the very first step on this one is going from a log equation to an exponential equation. And remember, logs always equal the exponent. So 4x plus 1 is equal to 2 to the 5th. 2 to the 5th is this right here. So 4x plus 1 is equal to 32. 4x is equal to 31. X is equal to 31 over 4. And 31 divided by 4. There's your decimal answer, 7.75. On this one, let's divide by 6 first. So we have natural log of 2x is equal to 5. Remember, logs always equal the exponent, so e to the 5th equals 2x. So 2x is e to the 5th. X is e to the 5th over 2. So we have e to the 5th, and we're going to divide that by 2. So 74.21 rounded. On this one, let's subtract 7. 3 natural log of x is equal to negative 1. We'll divide by 3, so negative 1/3. And remember, logs always equal the exponent, so x is equal to e to the negative 1/3. So e to the negative 1/3 is 0.72 rounded. 0.72 rounded. On this one, let's combine the logs. We have log base 6 of x times x plus 5 is equal to 2. We can distribute the x squared plus 5x equals to 2. Now logs always equal the exponent. So x squared plus 5x is equal to 6 squared. So x squared plus 5x minus 36 is equal to 0. We have x plus 9 and x minus 4 is equal to 0. So x is equal to negative 9, x is equal to 4, but we have a problem here. You cannot take the log of a negative number. So negative 9 makes that negative, negative 9 makes that negative also, but it only has to make one of them negative to be bad. So we're going to cross this answer out because it's a bad answer. 4 is just fine. Let's do the same thing here. Let's combine. So we have log base 2 of x times x minus 3, but then over x plus 2. And that's equal to 2. So we have x squared minus 3x over x plus 2 is equal to 2 squared. Remember, this 2 to the second power. Logs always equal the exponent. So x squared minus 3x over x plus 2 is equal to 4. X squared minus 3x is equal to 4 times x plus 2. X squared minus 3x is equal to 4x plus 8. So x squared minus 7x minus 8 is equal to 0. We have x minus 8 and x plus 1 is equal to 0. So x is either equal to 8 or x is equal to negative 1, but we cannot allow x to be negative 1 because it makes that one 0, makes that one 0, or negative, makes both of those negative, makes this one positive, but it's already a bad answer. It's already bad. 8 is just fine. The other bad answer would have been negative 2. Well, this is a very similar problem. They're just on opposite sides. So let's get them together. Minus log of x plus 3 minus log of 3 is equal to 0. So log of 2x minus 1, got minus, so over 3 times x plus 3 is equal to 0. So we have, let's go from log to exponential. So the base is 10, so 10 to the 0 is equal to this stuff right here. So 2x minus 1 over 3x plus 9 is equal to 10 to the 0, or 1. 2x minus 1 over 3x plus 9 is equal to 1. Now let's multiply this over. 2x minus 1 is equal to 3x plus 9, and we will minus x is equal to 10. So x is equal to negative 10. And negative 10 is going to make a couple of these negative. Now that's the only possible answer, so there's no solution to this. No solution.